This is going to be the final video of the series, and I'm going to try to keep this one short and sweet. Um, the last time I showed, or we went through, what would be the possible conservative estimates for future losses for a particular cause within a prioritized work comp code. In this case, it was work comp code 3632, which was the machine shop and the overexertion. And down below here, I also did it for 3632. Looks like struck by caught in. And as you can see, I guess you maybe can't see because it's not zoomed in. Did some estimates. Do we have any figures? So similar to the other one, I did some graphic work with the total paid to find out how much it might be. Again, that's the graphical representation. There should be a graph here with the number of claims. There it is. To estimate the number of claims, and what you do is you kind of just put it all together and try to come up with a conservative estimate. And that's what I was doing here, trying to figure out what might be the count, both from an average perspective and from the graphing, what the average cost is based on the dollar values we have, what the estimated claims will be and what it will be from the figure, and then what you actually are going to use. And then from that, you get a range of, so the conservative estimate is 46,000 for next year, and these are the ranges of requested investment based on the return on investment. Did it for slip, strips, and falls in the same job code. Let's see if we go down a little bit, it'll probably show us. There they are. So again, the estimate for this was 33,500 and the different required estimates. Did it for sharps as well. Again, it depends on what the priorities tell you. If they're strong enough, there's enough data, then you can try the forecast. Otherwise, if all you're doing is averaging and it's kind of all over the place, then you do the best you can. You're just trying to estimate, to forecast that, whether things going up, down, and what it might be. This is unknown. I even did it for that. This is the 3629, which is the precision parts, and I did overexertion for that. As you can see, the best fit line isn't the greatest, especially with that high mark right there. But you estimate maybe next year be about $10,000 in costs, and you can see the numbers are in this weird like 5 to 6 range. So the recommendations, this is what all this is working up to. Again, you're just based on what the priorities are, how much data is there, how well you're able to graph it and forecast things. If not, you're going to averages, and then you don't want to do that too much. And come up with priority. So I've got my priorities 1 through 5. I got the departments here. The first 4 of them are 3632. As you can see, I don't have all of the 3632s. I didn't do the unknowns. It gets to a point where there isn't much value in going any further. I got the overexertion. So I've got the estimated conservative number of claims that are going to occur the following year. I got the average paid per claim based on the data that's given. And then I have the forecasted, this is the conservative estimate forecast. And then come down here and I rounded up on a few numbers because again, these dollars, tens, 100s. So I've got my priority, department, cause, the loss, the requested investment, and then the return on investment. Again, it would be much, much easier in the real world that you could do this analysis and then this requested investment. It is actually something that you have researched and talked to workers and supervisors and maybe pilot tested as a very viable solution to controlling the exposure to whatever is causing these injuries. Or at least maybe it's something you're attempting and we think we can reduce it. Now, here we're assuming that we eliminate it all. Is that realistic? Not really, but again, we're just trying to learn the technique. The return on investment here, I've got I don't have the equations. The basic return on investment, so return on investment is equal to, I'm just going to leave that there for the sake of talking here. Is the benefit, which is the estimated loss benefit minus the investment amount, and that's all divided by the investment. That's the return on investment equation. I can do this to make it look good. Yeah, we can put that in the center, make it look even better there. So that's the equation. The benefit here is the estimated loss, saying that we prevent that from occurring, prevent that money from going out. We invest an X amount of dollars, we can get a return on that. So instead of losing that much, we invest this and then we get it back plus some, plus that much more in the first year. So it's a good deal. And again, this could be a lot less. Maybe it's not going to be this much. And maybe these solutions to the overexertion in these two areas are similar or the same and can be proliferated throughout the organization so that the actual return, the actual prevention of loss is greater, more realized. Here, see the totals go up to that much. But considering, how much was overall loss, and I don't think this even accounts for the outliers. The outliers aren't even being considered. One outlier may be this much. Prevent that from happening and you already have it. But trying to be conservative here with it. So return on investment is a percent. So this could be equal. I mean, I don't want to type anything in here because Excel thinks an equal sign means put something in. So it's times by 100%. You turn it into a percentage. So it's benefit minus investment divided by investment. So it'd be great if we knew what the actual investment was, because we have a conservative benefit, and then we could have an actual number here. I'm throwing numbers in here, trying to keep it between like a 20 to 40% for the first year, because you may have to calculate it for 3 years, 5 years, whatever it might be. It depends on what the company wants, how what their level of comfort in investment is, and what kind of return they want on that. But at least we've used the original data. Remember we looked at it back to here. We have this data here, and it's just the claim stuff. It's claim information. So, somebody did an investigation and they came up with some of these entries here, some of these codes, these variables within a claim. And then, money was paid for these claims. We've got these weird descriptions here. And we were able to take, 5 2/3 years of data. Let me go back to the descriptive statistics here. 5 2/3 years, 5.7 years, whatever, data, and use it to make priorities. Remember, this is all the original stuff. So the original total paid was 2 million. We're saying next year could be, for the specific area, so where to go, what to look at, that's the cause, and how much is going to happen next year if nothing's done. So we're going to study, investigate, try to identify the root causes, get the workers' input, the supervisor's input, use our, do some in-depth research on our own, maybe contact experts or whatever it might be, and then based on that, we're going to try to come up with solutions, and hopefully we can cost justify those solutions. So the final step is, what's the best way to present this to management? And that's something you're going to have to figure out. Figures, tables, this is what's good. It needs to be brief. It needs to be direct. It needs to be, this is, here's a potential gain based on past losses. And, you might say, well, how can you justify that? And the justification, although not stated here, is that whatever was done before wasn't enough. That these causes are reoccurring. There are repeat claims based on these causes in this area. Whatever was done to investigate and try to remediate isn't working, or maybe the solution is too expensive. So maybe this is what the company wants to live with. Who knows what? But the key is, what is the best way to present this? Because we're trying to persuade management to invest in a safety program, and that's what this technique is all about. Try to get management to invest, come up with better controls, better solutions, and then over time, if we can show that these numbers are going down, that the costs are going down, that means it was a good investment. Thank you. Now let's go to the next one. Let's do the same thing in this department for this cause. So that's the end of the series of videos. I may add some more later, get creative with some of the data analysis, some additional things that could be looked at. But basically, for the project that's being done in the class, that's what this was built for. We took it from start to finish, and hopefully then you can finish it off by presenting it in your executive summary and paper and in your presentation. And be sure that you put notes in your Excel document explaining each step. So don't just give me tables. Explain what this stuff means. What are you going to do with it next? Because I need to grade you on your ability to understand and comprehend each step of the process. So that's it. I hope you enjoyed this video series, and I hope this helps you.